Good morning, everybody. Yeah, I think this homework is a good example of what we're going to find often the rest of the year. We're finishing up chapter 6, and then we'll do 7 and 8 and 9. And I think what you're going to find is a lot of the stuff that's left in the book we have been doing in warm-ups and Pizzazz worksheets and other worksheets throughout the year to sort of pre-teach that. So there's going to be very few things, I think, coming up that are going to be brand new to you, okay, which is kind of cool, okay? So, yeah, you get other chances to learn. Keep doing those warm-ups, and then see how hard you think these things are as we go forward. But I think you're going to be pleasantly surprised what we say, okay? So this is the lesson for CPM 6.2.3. Okay, you can see it right here. We're talking about variables and x's, and how do we use these x's to represent shapes, and why are we doing this? And what we're doing is we're playing around the variables a little bit, so they aren't so foreign to you, and you're comfortable with them. Well, when you get to using variables, which we'll be doing a lot in the future years in math and even in science too. Okay, so other subjects, economics, statistics, there's a lot of different things where you end up using variables going forward. So don't be afraid of them. They're kind of cool. They're valuable to you. And I would bet that you use some already and you aren't even really that aware of it. You just sort of plug things in. Anyway, we're doing 6-96 through 6-100. And 6-96 says to copy those diagrams of the algebra tiles. And remember what the algebra tiles are. There's these things here that you did not get to play with in person, right? Which probably would have made it a little bit easier. But you guys are up to the challenge and are moving forward anyway. And we're going to try to do this without. So if I have this x squared, what is each side? If this tile represents x squared, each side is going to be an x, right? Because x times x is x squared, right? Now, if this has the same length as a side, I think that's an x too, and the area is x. What times x is x? Well, 1. And that makes sense because we call these a unit cube, okay? So that's a 1, that's a 1, that's a 1. So the perimeter of this shape is the distance all the way around. If I start here, I'm going to do x plus 1 plus x plus 1 plus 1 plus 1 plus x. And when I write all that out, when I get done, I want to put all of the x's together and all the 1's together to simplify it. What's the other term we use when we put all the x's together and all the x squares together sometimes, and that's called combining like terms, okay? And just think of that. I'm putting all the apples together and all the oranges together, all the bananas together, combining like terms, okay? So I can put all the numbers together and I'll put all the letters, but the letters to the same power. If I had x squares and x's, those are two different piles, okay? All right, so you're going to add all those up, okay? On this one, again, you have an x here, x here, x here. What's on the end here? That's a 1, a 1. This is an x. What's down here? Another 1, another 1. Add them all up and then combine them, okay? I'm going to let you try that. Okay, for the Jack and Jill problem, looks like Connect 4, combination between Connect 4 and graffiti worksheets, right? But the easy ones, all positive, right? Remember graffiti now, we're doing the 4-quadrant ones. So this 0, 0, also known as the origin, and it starts with an O, original, where the starting point of everything goes in the middle of our graffiti worksheets instead of on the lower left corner. And we have a graffiti worksheet coming this week for you. So I know some of you guys have been asking if we can do another one. We have another one coming this week. So anyway, we need to identify all of the dots, okay? So why don't we do Jill's in red, right? All the dots. and Jack's in blue. Okay. And we can color in Jack's. So it's 4. I did red and blue just because I didn't want there to be any confusion when you look at, I can see you guys now with a magnifying glass up on the computer screen trying to figure out, is that filled in or not? Anyway, so let's use red and blue. Remember, when we identify a place on the grid, on the coordinate plane is what they call it, coordinate plane. Remember, coordinate, that's when two things go together, right? So I need a how far over and how far up. They coordinate, they go together to make that point. And remember, we have the x first and the y second, okay? X comma y, and remember it's always over first, up second. And if we had 4 quadrant, over would have arrows going both directions, and up would actually sometimes be down if it was negative. Okay, but the first number is how far over, the second number is how far up. So how far over did I go on this dot? I went over 1 and then up 5. So that first dot, we're going to say that's 1, 5. Okay, what's the second dot? Now I went over 2 and I'm going up 4. So let's say over 2, up 4. And I think you get the picture. What's this first one for Jack down here? Over 1, up 2. And we could say this next one, over 1, up 3, and so on. So I think that's enough of a start that you guys can finish. And most of you probably didn't need that help, huh? Right? You guys already got this. All right, now we're talking about Molly and Nancy and who knows what they're doing and who is still going to learn something because they're going to find a mistake. Okay, Molly says that 2 plus 3 times 4 is 20, and Nancy says 2 plus 3 times 4 is 14. Well, and when you look at it, I can see how Molly got that because 2 plus 3 is 5, and 5 times 4 is 20, right? And for Nancy, I can see how she got hers because if she did the 3 times 4 first, she got 12, and 2 plus 12 is 14. So who's right? Because it looks like they're both right. And remember, what we have to have in math, in anything in life, you got to have some rules, right? So because they both can't be right, we got to figure out what makes it right. Is it just, do I add this first and then multiply like Molly did, or do I multiply this first and then add like Nancy? Okay, so you are going to look up what you remember from order of operations and try to figure out what is the correct order between adding and multiplying. And then that will get you the right answer. Okay, and I think that you have this written down. I hope you have this written down in your composition book, the rules for order of operations. Otherwise, you're going to have to go back and find it. Okay, all right. I'm going to leave that one up to you. Here we got 3 pieces of licorice, and I know what you're thinking right now. Why didn't you use the red pen for the licorice? Because, licorice is like almost always red. Why'd you use the blue pen? And I agree with you. That was a mistake. I should have done red. I think you guys can still do this. I drew 3 pieces of licorice there, and there's 4 people getting it. How big is each piece? Well, if there's 4 people, there's only 3 pieces. Someone's not getting any, right? No, you can divide it. Okay. No one's going to get a full piece, though. Okay, so I'm going to let you figure that out, but I'm going to give you a hint. If you took each of these pieces and made it into fourths, first you divide it in half, then you do both halves in halves, and now you have fourths. Now it makes it easier. Okay, I'm going to let you try that. On 6-100, the first thing we have to do is look at 24 and find all the factors. And I want to remind you, whenever you're talking about factors, think to yourself, factors fit, right? That's an alliteration that helps us remember that factors fit, right? 20 is not a factor of 4 because 20 does not fit into 4. But 4 is a factor of 20 because 4 fits into 20. Nice even 5 times, right? 4 times 5 is 20. So we're looking for all the numbers that fit into 24. And I think it's easiest if you start with 1 times the number. And then if it's even, you're going 2 times the number, whatever number, 2 times what equals 24. 2 plus 4 is 6. 3 goes into 6. I know 3 goes into it, right? Do that. And then when these numbers come together, you know you're done. You don't have to do all the numbers between 1 and 24. Now, on this one, we're looking for the smallest number that 1, 2, 3, 4, and 5 are all factors of. Okay, now 1's easy. 1 goes into everything. But if it's 2, that tells me this has to be an even number. If it's 3, this tells me that when I add the digits, it's going to be a number that 3 fits into. 4 fits into the last 2 numbers is the trick. And 5, it has to end in a 5 or a 0. Now, can it end in a 5? It can't. It's not if it's even, right? So it has to end in a 0. So I know my number, the last digit, is going to be a 0. Okay? So you're going to try to figure out what number goes into just 1, 2, 3, 4, and 5. And I think the trick is pretty much the 3, 4, and 5. Okay? Because 2 goes into every 4. Right? So if 4 fits into it, 2 is going to fit into it. All right. And the next one is you find the second biggest number. So this is going to be a challenge for you. Okay. Guess and check might be your best technique. However, I have given you some hints. Sometimes if numbers are right next to each other, like 4 and 5 or 3 and 4 or, 99 and 100, the smallest number that both those numbers fit into is, okay. So we'll come back and I'll teach that hint if you're stuck. Okay. All right. If you get stuck today, though, go see your teachers, ask them for help. Remember, it's like giving us cookies. All right. Have a good one, everybody.